Yeah, welcome to today's practical. In today's practical, we want to determine the acceleration due to gravity using simple pendulum or pendulum bulb. As you can see, this is the arrangement of the apparatus. We have the rotor stand, that is this. We have the cock, this one is the cock. We have the threads and the pendulum bulb. As you can see, these are the arrangements. The setup here is exactly what is on the board. And the thread is of length from 0 to 100 centimeter. That's the length. But the initial length we are going to take is a length of 80 cm. And we take a length of 80 cm, we determine the time. We determine the time for that, the number of us, the time for oscillation for the 80 cm length. We also find the T2 for the same 80. Then we sum these two and divide by 2. That will give us T average. T average is T1 plus T2 divided by 2 will give us T average. Then period is the number of oscillation. The body will oscillate for 20 times. As you displace the body, when you displace the body, it oscillates. When it goes like this and move like this, it has covered one revolution or one oscillation. So we count it for 20 watts oscillations. Then after that, we record it. We record the time. That is T average divided by 20 will give us this. Then T square is the value we get here. We divide it, we square it. That will give us this value. So we repeat the experiment for various values of length. We keep decreasing the length up to 30 cm. So this is how we are going to conduct this experiment. Now, right now, we can start off the experiment. As you stand up and let's see how it goes. Now, first of all, you measure a length of 80 cm. We try to measure a length of 80 cm to the center of the bulb. So this gives us a length of 80 cm is here. So this one is 80 cm. After that, you now displace the body at a smaller angle. As you can see, this one has formed a right angle triangle. If you do it like this, this is a large angle triangle. And just like this, but the angle you're going to use will be reasonable. So you displace the body like this. You see, one is that you see the body is moving 0, 1, 2, 3. That's how you'll be counting it in your using your what stopwatch. Do you get it? So that's how you're going to conduct the experiment. Now you can come up and have the experiment done. Okay, that is the length, right?
But 80. That's 80. 3, 4, 5, 6, 7, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20.
What is the time?
Yes, sir. Yes, sir. At 1.41. 36.19. That's 1.17. 28.55. 79. 24.60. 24.60. 1.81. That's 6.28.
Thirty-one point four one plus 31.17 divided by
31.29.
31.29.
31.29.
28.55 plus 28.65 divided by
28.59.
divided by 20.
1.81.
1.29 divided by 20.
1.57.
81 square.
3.276.
1.57 square.
2.465.
Square of 1.4.
2.045.
Okay, now we have already concluded with the experiment. You can see this is the table of value. At these are various values of the length. This is the time for this length. Then that's we repeat the time and get this one 36.19. Then these are the repeated time T2. Then this is the T average. That is this plus this divided by 2 give us this, and so on. Then this is T, the period. The period is 36.28 divided by 20. Number of oscillation is 20. That will give us this. All this divided by 20 will give us this column. Then the square of this column will give us this. Now what we are going to do is to plot the graph of this square against L. We are going to plot a graph of this against this one. Now in the plotting of the graph, we will see the behavior of the graph. And then from there, we can calculate the acceleration due to gravity. The results of the experiment, as you can see, we plotted t-square, on the vertical axis, and the L on the horizontal axis. As you can see, when this one is, when L is 80, we plotted 3.27, that is 3.28 somewhere here. When this one is 80, we plotted 3.27, that is, this is 3.0, 3.05, 3.1, 3.15, 3.8. Look at this where we plotted at that point. So that is this point here. Then we have another point we plotted here, various points. These are our various points. So these are various points. Now, as you can see, this is the slope, the right angle triangle. Your right angle triangle must be reasonable. And it's not supposed to be a very small right angle triangle. This is large right angle what? Triangle. Now, at the end of this one, we were able to get our slope. Our slope is this one. We were able to get our slope. As you can see, our slope, we have change in t-square over change in L. This is t-square. This is a positive graph. So that is why we have t-square 2 minus t-square 1 over L2 minus L1. This is t-square 2 is this point here. This is t-square 1. This one is L2. This is L1. And that is how we get these values here. At the end of the arithmetic, we were able to get 0.04 second square per centimeter. That is our slope. Now, the theory of this experiment is, this is the theory of the experiment. As you can see, this is the theory. That is the theory behind the experiment. Actually, we're supposed to have explained the theory before. This is the theory of the experiment. That is T equal to 2 pi root L over G. That is the theory where if we make T square, we have T square is equal to 4 pi square up into L over G. So if we plot this one, this is a graph of T square against L. This one becomes the slope of the graph. So the slope of the graph is equal to 4 pi square over G. Now, trying to make G the subject of the formula, we have 4 pi square over slope. Now, this is 4 is this one, pi is 3.142 square over the slope. Our slope is this one here, that is 0.04. That is our slope. Then, this multiplied by this will give us this. This one is the slope, which is this. So, 39.4886 divided by 0.040 will give us 987 cm. This is where we stopped. This is 39.488 divided by 0.04. That gives us 987 cm per second square. So when we divide this value by 100, that is by 100, the result will now be, we are going to have a result like 9.87 meter per second square, which verifies the theory. So our result, the experimental value has also verified the theoretical what? Value, meaning that our result is correct. So we have already determined 9.8 as our acceleration due to gravity, which also is in line with the theory. So this is the end of the experiment for today. Thank you.
Thank you, sir.